Today we're going to continue with statistics and we're going to be looking at standard deviation today. So first off, what is standard deviation? So the standard deviation is a measure of how spread out numbers are in a data set. So when the standard deviation is low, that means the numbers are close to the mean, so they're more consistent. And when the standard deviation is high, the numbers are more spread out from the mean, so they are less consistent. Okay, we're going to come back to these terms more consistent, less consistent in the next couple of slides. So we're going to first think about, look at a couple examples of comparing data. So let's look at this example first before we get into actually calculating the standard deviation. So two golfers, Andy and Jim, compare the lengths they hit 10 shots with their drivers off the tee. The table below shows the statistics for both players. So each player, they're going to hit the driver off the tee and they have measured how far in yards each of those shots are. So for Andy, the mean number of yards is 200. And so the mean as in the average number of yards, and the standard deviation is 34.8. So that's a fairly high standard deviation. For Jim, the mean number is also 220 and his standard deviation is 7.9. So let's make two comments about these results. So the first comment we're going to suggest, and we can clearly see, is that the mean number of yards they hit their tee shots is the same. However, when we are commenting on these, something that's really important is that you do not use the word mean. Okay, mean represents the average. So whenever you go to write mean in your comments, change it to average. So the average number of yards they hit their tee shots is the same. So that's our first comment. Our second comment is going to do with the standard deviation. And thinking back to the previous slide, when I said the higher the standard deviation, the less consistent, meaning the more spread out the data is, and the lower the number, the more consistent it is. So the comment that I'm going to make is Andy is less consistent in the length he hits his shot off tee than Jim, since 34.8 is greater than 7.9. So Andy is less consistent since his standard deviation is greater than 7.9. However, we don't write the word, just like in our mean comment, we don't write the word because his standard deviation is greater. We're using the term less consistent if it's higher or more consistent if it's lower. It is quite tricky to get your head around the terminology behind this, but it's really important that we get these right. Basically, we are not using the words that are in our table, mean and standard deviation. We're going to change the word mean to average, and we're going to change the word standard deviation to either less consistent if it's a higher number or more consistent if it's a lower number. Let's look at another example. So two teachers work in the same school and live in the same street. They both drive to work in their own cars but take different routes each time, claiming they know the quickest way to work. The table below shows the statistics for 1 week. Feel free to pause here if you want to give this a go yourself. Okay, let's just go over the two comments that we're going to make. So make two comments about these results. We're first going to comment about the mean. So Jane, her mean or average time to drive to school is 23 minutes and the standard deviation is 8.9. For Tom, the mean is 20 minutes and the standard deviation is 16.4. So the comment that we're going to make firstly about the mean is that Tom seems to have the quickest route as his average time to get to school is 20 minutes compared to Jane's 23. So we're changing the word mean to average and saying his average time is 20 minutes compared to Jane's 23, and therefore he has the quickest route. And for comment about the standard deviation, the length of time Tom takes to get to school is less consistent since 16.4 is greater than 8.9. So although he has the quickest average time, the standard deviation, so the length of time it takes, is actually less consistent. So over the week, his time hasn't always been 20 minutes. It's been more varied, less consistent. Okay, again, we're going to come back to some examples like this near the end, but for now, we are going to look at important notes to do with comparing data before we move on to calculating the standard deviation and how we do that. So important notes to take from those previous two examples. When you're comparing mean, you never say mean, so whenever you're writing down your words, you don't want to say the word mean, your mean time or anything like that. You want to change the word mean to average. And when you're comparing the standard deviation, you don't want to ever write the word standard deviation. If it's a higher standard deviation, that means it's less consistent, which means it's more varied or more spread out. And if it's a lower standard deviation, that means it's more consistent, which means it's less varied and less spread out. Like I said previously, it is quite tricky to get your head down the less, the more, and everything like that, but just think the higher the number, the less consistent, the lower the number, the more consistent. Okay, now let's look at actually how we go about calculating the standard deviation. Okay, so our standard deviation formula looks like this. I know it definitely looks quite crazy, but I'm going to break it down and show you what each part means. So first off, SD stands for standard deviation, or it could just be written as S as well. So you could just have S. And then we have this funny little looking symbol here. This actually means the sum of. So in our formula here, we've got the sum of all of this added up and then squared. So all of these terms squared added together. So the sum of. And this symbol, X bar, we call it. So X bar, that represents the mean. And last thing, N, that represents the number of pieces of data in this sample. So say we're calculating, like previously, the time it takes to get to school over the week. So you go to school 5 days, so N in this case would be equal to 5. Again, like I say, it looks really quite crazy, but once we break it down and go through some examples and how to use it, hopefully it will be more straightforward then. So a little bit extra, we said the mean was X bar, okay? The deviation of the score is how much the scores differ from the mean, so how much they deviate. So the deviation is X, so that would just be your whatever number it is in the sample, take away the mean, so how much it differs from the mean. And then the next step was to square it, that was part of our calculation. Again, you'll see this all come together in our next example. So the standard deviation is the square root of all the deviations squared, the sum of them added all together, divided by the number of pieces of information in the sample, take away 1, and you're going to square root all of that. So you really need to be careful when you're plugging the last bit into the calculator that you're square rooting this whole top term divided by the bottom term. Okay, let's go through a first example. So the height of 6 Christmas trees at a garden centre in metres are 1.1, 1.7, 1.9, 2.1, 2.3 and 2.9. Let's calculate the standard deviation of these. So the very first thing we want to do, and as you see, I'm going to go through steps, and when you are calculating the standard deviation, these are exactly the steps that I would like you to take. So the first step is you're going to calculate the mean. And to calculate the mean, you're going to add these all together, and then you're going to divide them by how many is there. So you're going to add all these lengths together and divide them by 1, 2, 3, 4, 5, 6. So 12 divided by 6 to get a mean of 2. The next thing we're going to do is start calculating our standard deviation. And whenever we're calculating our standard deviation, we always want to draw out a table that looks just like this. So you want 3 columns, okay, and your X just represents each of your individual numbers or terms in your sample. So that's your x, and all we've done is we've written down each of these numbers. So we've written down 1.1, 1.7, 1.9, 2.1, 2.3 and 2.9. It doesn't necessarily have to be in order, but it's much easier and much neater if it is. And we're now going to calculate our deviation. So how much does this value differ from the mean? So we're just going to go through each step and fill in each box. So the first one we're going to do is there's this x subtract x bar, which is the mean. So we're going to take 1.1 subtract 2 to give us negative 0.9. This time we're going to take 1.7, subtract our mean, which is 2, so 1.7 subtract 2 is negative 0.3. We're then going to take 1.9 subtract 2 to give us negative 0.1. Then 2.1 subtract 2 to give us 0.1. 2.3 subtract 2 to give us 0.3. And then 2.9 subtract 2 to give us 0.9. Once we have done that, so we've found the deviation, how much our x value differs from the mean. We now want to square each of these. So all we're going to do is take negative 0.9 and square it to get 0.81, negative 0.3 square it to get 0.09, negative 0.1 square it, and remember when you're squaring it, you're timesing it by itself. So negative 0.1 times negative 0.1 gives you negative 0.01. And then so on and so forth. And you will notice if you've done it correct, you should get, well, not necessarily in this case, but because you have the same values here, you will see that they're the same. When you square it, that's just because, when you times a negative by a negative, you get a positive. So that's some things may happen. Okay, and obviously if you get a negative when you're in your squared column, you have made a mistake, because whenever, regardless if it's negative or positive, if you're squaring a term, you will always get a positive answer. Okay, so we've found our deviation, we've then squared our deviation, and the next step we're going to do is, remember, this is the sum of all of our deviations squared. We're going to add them all together. So because we have found our deviations all squared, all we're going to do is add all these together. So add 0.81, 0.09 and so on. So add this last column up to get 1.82. So already we have tackled this really tricky looking part of our formula using this table. So we've broke that down and we've got 1.82. Now we're going to go ahead and calculate the standard deviation. So the standard deviation was the square root of the sum of our deviations squared divided by n take away 1. So in this case, our n is 6, because that is the number of terms in our sample. So we are going to take, because we've calculated this bit at the top, we're going to take our 1.82 on top of our fraction, and then we're going to divide it by 6 take away 1 to get 5. And now we're going to stick this into your calculator. So you're going to click the fraction button and the square root of the whole fraction. Or you could calculate 1.82 divided by 5 first and then square root it, whatever way you prefer. If you're confident using your calculator, I would just go ahead and put this straight in. Okay, so then now you've got your standard deviation of 0.60. Okay. I'm going to go through another example because I know this is a lot, and again it looks quite tricky, and it's all about remembering the steps and remembering what goes in your table. Feel free to pause here and copy this example down, especially all the steps. Okay, second example. This example has to do with the contents in a sample of 10 tubes of toothpaste are measured in millilitres. The results are shown below, so we've got 10 results, all in millilitres. We have to calculate the standard deviation. So first step, as always, we're going to calculate the mean. And to do that, so means represented as x bar, we're going to add all the terms together and then divide them by how many is there. So we're going to add these all together and divide them by 10. So you've got 646 divided by 10 to give you 64.6. So this is our mean. We're now going to go ahead and start calculating our standard deviation. And to do that, we need our table. So it's slightly longer than last time, but we've still got the exact same columns. We've got our x and then all our values in there. And notice if you've got the same value twice, they still have to go in there, each individual term and value in its own row. Our second column is our x value subtract our mean, so the deviation from the mean. So our first one, we're going to take 60 subtract 64.6 to get negative 4.6. Then we're going to take 62 subtract 64.6 to get negative 2.6. Be careful, make sure you are taking the x value and subtracting the mean, even if that x value is smaller. So 64 subtract 64.6 minus 0.6, and same again. Now 65 take away 64.6, and then 66, and lastly 67. Once we've done that, we're just going to square each of these terms. So the first one, we're going to take negative 4.6 squared, or negative 4.6 times negative 4.6 to get 21.16. And if you just go ahead and use your calculator to square each of these terms. Okay, so we found our deviation and then we've just squared each of those numbers. Once we've got here, so we've filled in our table, we're then going to find the sum of our deviations squared. So the sum of meaning adding them all together. So we're going to take this last column and work down the way and add them all together to get 44.4. So now we've got this tricky part out of the way of our formula, we can go ahead and calculate the standard deviation. So standard deviation, this is our formula. We're always going to start by writing down our formula. So we're going to take that sum of 44.4 divided by n is 10, take away 1 to give us 9, because remember n is the number of terms in our sample. And then you can just stick that straight in your calculator, and the standard deviation is 2.22. Okay, again, if you need to pause here and copy that down, that's absolutely fine. I would like you to pause the video here and try this question. So a machine in a factory is stamping out components. A quality controller counts the number of rejects per minute made by a machine. So the rejects per minute, 1, 2, 3, 3, 4, 6, 8 and 9. Calculate the standard deviation. And remember, you have to draw out this table here. So you've got your x terms, x minus x bar for your deviation, and then squaring that deviation. So start by calculating the mean, and then draw out your table and fill it all in, and use the previous example to help you. So pause here. Okay, hopefully you've unpaused and managed to give that a go. First off, we're going to calculate the mean by adding all those terms together, dividing it by how many is there. So there are 8 to get 4.5. We're then going to go ahead and start calculating our standard deviation, but before we do that we have to fill out this table. So we've got 3 columns, our x terms, and we've written them all in. We're then going to calculate this deviation, which is x subtract x bar, which is our mean, so how much our x value deviates from our mean. So you should have negative 3.5, negative 2.5, negative 1.5, negative 1.5 again, negative 0.5, 1.5, 3.5 and 4.5. These questions are quite tricky because if you make a tiny little mistake somewhere here, then your whole standard deviation will be wrong. But make sure you're really, really careful, and as long as you're filling all of this in, you're showing you're working in your table, you can still gain the majority of your marks with these questions. Okay, then we're just going to take our deviation and we're going to square each one. So you should have 12.25, 6.25, 2.25, 2.25 again, 0.25, 2.25, 12.25 and 20.25. Once you've done that, we're going to add all of that last column together. You should have 58. And now we are going to calculate the standard deviation. So you're going to write down your formula to start with, And remembering that n is 8, so 8 take away 1 is 7. So we're going to take our 58, divide it by 7 and find the square root of that. So you should have 2.88. So really well done if you got that correct. Like I say, it's super easy to make a tiny little mistake here, so you just really need to be super careful when you're filling in this table. Okay, I'm going to show you one more example, sort of combining the comparing data that we've looked at the very start of this slide, of this presentation, and calculating the standard deviation. So often you might see questions that look like this. So let's say 6 friends joined Super Slimmers. Their weights were recorded and the results are shown below. So their weights were 75 kilograms, 72, 74, 81, 90 and 98. The first task is to calculate the mean and standard deviation. Part B then says after 6 weeks, the mean weight was 74 kilograms and the standard deviation was 8.6. That is when we're being asked to compare. So we're going to start with part A and calculate the mean and standard deviation. So the mean, add them all together, divide them by how many is there. So we're dividing by 6 to get 80. Our standard deviation, we're drawing out our table, our x values, we must write every single one of them in and then calculate x subtract our mean. So you should have negative 15, negative 8, negative 6, 1, 10 and 18. I'm just going, slightly quicker through this just so it's not too repetitive at all. But again, if you have any questions, make sure you ask. And then we're going to square each of these terms to get the last column all filled in. Again, using your calculator to make sure you get these correct. And then we're going to find the sum of that last column to get 750. Once we've filled in that column, we can calculate our standard deviation, and n is 6, so n take away 1 gives us 5, which gives us 12.25. So that's us done part A. We've found our mean and we've also found our standard deviation. Our last part is to compare the mean and standard deviation. So this was before they started Super Slimmers, and we know after 6 weeks the mean was 74 and the standard deviation was 8.6. So let's compare this data. So for the mean, the average weight after the 6 weeks is lighter because 74 is less than 80 kilograms. So we know the average, and remember, we're not using the word mean, we are using the word average. And then our standard deviation, we're going to make a little comment about that. The weight after the 6 weeks was more consistent since 8.6 is less than 12.25. So remember, the lower the number, the more consistent, which means the less varied or the less spread out. So that was just a little example to see the 2 points from today combined into the one question. So make sure you've got these notes copied down, and if you have any questions at all, please don't hesitate to ask. Okay, so another question for you to try. Machine A weighs 6 packets of chocolate discs, and you can see all the weights there. First off, you have to calculate the mean and standard deviation. For part B, machine B gives a mean of 40.3 grams and a standard deviation of 0.5. The question that you need to answer once you've calculated part A is which machine is more consistent. So if you pause here and give this one a go. Okay, let's go over the answer. So first off, you need to calculate the mean. So you're going to add all your 6 weights up and then divide them by 6. So you should have 241.8 divided by 6 to give you 40.3 as your mean. We're now going to calculate the standard deviation by first using our table. So we've got 3 columns. We've got our x values, which is all those terms written down. And then, so like I said before, it doesn't matter if they're in order, so it's absolutely fine just to write them straight down. We're now going to calculate the deviation, so how much this mean varies from our x values. So you should have 0, minus 0.3, 0.5, minus 0.4, minus 0.1 and 0.3. We're then going to square each of these terms. So you should have 0, 0.09, 0.25, 0.16, 0.01 and 0.09. Once you've filled in those three columns, you then need to find the sum of the last column by adding them all together to get 0.6. And now we can calculate our standard deviation. So we're going to replace this top part of our fraction with 0.6, and our n is 6, so n take away 1 is 5. So you should have the square root of 0.6 divided by 5 to get 0.35. So well done if you've got that correct. For part B, it then says machine B gives a mean of 40.3 grams and a standard deviation of 0.5. Which machine is more consistent? So firstly, we can see that the mean is the same, so that means the average weights are equal. We weren't asked to compare that, but we're just stating a fact there. Okay, so which is more consistent? We know that consistency has to do with the standard deviation. So machine A weights are more consistent than machine B, since 0.35 is less than 0.5. So remember, we said near the start of this lesson that the lower the standard deviation, the more consistent, which means it's less varied or less spread out. So because machine A has a lower value, then that means it is more consistent. If you happen to swap these round, that means machine B is less consistent. So you have got an opportunity to get a mark if you write it the other way. You just need to make sure that you are either saying it's more consistent if you're referring to a lower number, or it's less consistent if you're referring to the higher number. So really, really well done if you got a mark for that last answer.